Welcome to this explainer where we're going to completely demystify mechanical engineering. I want you to forget that outdated, dirty factory stereotype for a minute. Today, we are diving into exactly how this incredibly versatile field designs the modern physical world we live in, from electric vehicles and reusable rockets all the way to life-saving medical devices.
Here's our game plan for today. We'll kick things off by defining what the field actually is, map out that 4-year college grind, get real about careers and paychecks, check out the cutting-edge future, and finally, figure out if this is the right path for you. Let's jump right in.
All right, starting with Section 1, defining mechanical engineering. What are we actually talking about here?
Get this. It is a staggering reality that mechanical engineers are responsible for designing 95% of all manufactured products globally. We're talking about a field employing over 3 million professionals worldwide. Simply put, if it moves, if it generates power, or if it transforms energy in any way, you can bet a mechanical engineer is behind it.
So at its core, this discipline is really about taking the fundamental principles of forces, motion, and energy and putting them to work. You're taking physics, throwing in material science, and applying some pretty heavy math to build literally everything. And I mean everything, from tiny, microscale medical devices to massive, sprawling renewable energy plants. You aren't just sitting there analyzing data, you are bringing actual, tangible physical creations to life.
Which brings us nicely to Section 2, the 4-year curriculum. What are you actually going to study? Okay, so your college progression is going to look a little something like this. Year 1, that's your boot camp. Land down those crucial math and physics foundations. By year 2, you're shifting into the actual ME specialization. Think thermodynamics, fluid mechanics, and basically testing materials in the lab until they literally snap. Then year 3 hits, and that's your deep dive into machine design, heat transfer, and advanced manufacturing. And finally, year 4 is the peak. You're taking advanced electives like robotics and pouring everything you've learned into a massive, multi-month capstone project.
But what does all that late-night studying actually prepare you for in the real world? Let's step into the shoes of an automotive design engineer for a second. You kick off your morning syncing up with your team. By midday, you're deep into intensive 3D CAD modeling and FEA, that's finite element analysis simulations. Basically, you're pushing your designs to their absolute digital limits. Post-lunch, you're probably hashing out production trade-offs with the manufacturing team. And to wrap up the day, you're in the prototype lab, analyzing exactly why a physical part failed. It's just this continuous, exciting loop to design, simulate, and test.
All right, it's time for some brutal honesty. In Section 3, careers and compensation. Let's talk roles and salaries.
Looking at Indian market data, your financial roadmap is pretty clear. At the entry level, you're looking at somewhere between 4 to 7 lakh per annum. Now, as you level up your skills, that bumps up to the 8 to 15 lakh range mid-career. And ultimately, if you carve out a specialized niche or step up into management, you can absolutely scale up to 20 to 50 lakh or even more as a senior technical leader.
Now we've got to address the elephant in the room and compare this to computer science, right? Because while ME gives you that unmatched, deep satisfaction of building tangible stuff you can actually touch, it absolutely comes with slower project cycles. I mean, designing a new car takes years. Pushing a software update takes weeks. And because of that slower cycle, ME does tend to have lower starting salaries compared to the fast-paced digital world of software engineering. It's a field that really requires patience and playing the long game.
The really crucial thing to understand here is that your specific role is going to completely dictate your day-to-day reality. Are you a design engineer? You'll be practically living in CAD and PLM systems crafting 3D models. But if you're a manufacturing engineer, your whole world shifts to optimizing the factory floor using CAM software. Or maybe you're a thermal engineer, running complex fluid dynamics simulations to make sure EV batteries don't overheat. Basically, your exact specialization completely defines the toolkit you use every single day.
But here's what makes this degree so incredibly bulletproof. These roles are desperately needed across a massive variety of industries. If the traditional automotive sector takes a sudden hit, no problem at all. You can seamlessly pivot your career over to aerospace, defense, or the wildly booming renewable energy sector. That core foundation you built in thermodynamics and mechanics, it never goes obsolete. You just apply it to a completely new set of problems.
Let's shift gears and look ahead with Section 4, Innovation and the Future. What are the cutting-edge frontiers?
So artificial intelligence is absolutely revolutionizing the daily workflow here. AI is already automating a lot of routine CAD drafting, meaning those simple brackets and standard housings are just getting generated by algorithms now. On the factory floor, deep learning is powering practically perfect visual quality inspections, and AI is even supercharging standard simulation setups, predicting stress distributions in a matter of seconds instead of hours.
So what does that mean for you? Well, because AI is taking over the tedious calculations and the basic modeling, your value as a human engineer completely shifts. You're going to be the one focusing entirely on system-level design thinking, creatively defining the actual problems, and integrating complex systems across mechanical, electrical, and software domains, not to mention ensuring strict safety standards. The future absolutely belongs to the engineer who can creatively pilot these AI tools, not the one trying to compete with them on basic math.
And we are seeing this human-led frontier play out in some mind-blowing ways right now. Take Tesla's gigacasting, this massive manufacturing breakthrough where they cast huge sections of a car body as a single piece of aluminum. Or look at the insane thermodynamics required to build SpaceX's reusable Raptor engine. Even at the university level, like IIT Bombay's racing team, students are integrating incredibly complex mechatronics to build electric formula cars completely from scratch. This is exactly where theory collides with exciting real-world action.
Which brings us to our final stop, Section 5. Is ME right for you? Let's use this framework to figure that out.
You really have to weigh the pros and cons here. On the plus side, you're getting insane career versatility, rock-solid job stability, and the deeply satisfying feeling of seeing a physical product you designed out there in the real world. But on the flip side, you are usually geographically tied to physical hardware labs or factories. You can't exactly build a jet engine from your local coffee shop. Plus, as we mentioned, you might see slightly slower early career financial growth, and you absolutely have to commit to constantly learning new tech.
So ask yourself honestly right now, do you genuinely care about the forces, mechanisms, and physics operating inside the devices you use every single day? Like, when you see a car drive by, do you instinctively picture what's happening under the hood? Your gut reaction to that question is incredibly important data for your future.
I'll leave you with this final, empowering thought. When you're deciding whether to take on this rigorous 4-year journey, your genuine curiosity about building the physical world is a far better predictor of your ultimate success than just your raw math skills alone. If physics, machines, and hands-on problem-solving light a fire in you, you've got exactly what it takes to thrive. So the ultimate question is, are you ready to step up and actually design the future you want to live in?